All right, let's try to put this baby to bed. I hope that after that last video that you're really thinking about the division of fractions algorithm. But I'm just going to generalize it, speak it out one more time, but you really are going to need to take the time to think through this for yourself. Now, there's going to be some more work to do after this too, but it's really imperative that you take the time to let your brain work to make sense of this. So here it is. A recipe calls for not 1, but C cups of flour. You only have an A over B cup measuring cup. Now, A over B is A copies of 1 over B. Keep that in mind. How many filled A over B cups are needed to meet the requirement? So, it starts, if you think back to the last video, it starts with this. We know that we needed 1 cup of flour, then B over A filled A over B cups. So, how did we get that? In my last video, we started with just 1 over b. 1 over b, b times makes 1. So a over b, b over a times makes 1. And so that was the first thing. But then we didn't need 1 cup of flour, we needed c cups of flour. And so we have to multiply by a factor of c. And so c times b over a. So the algorithm is now visible. C divided by A over B is the same as C times B over A. Keep the first number C, change to multiplication, take the reciprocal of the second number, and that's how it works. But I hope you can see the thinking behind it. Now here's an interesting thought. You're going to see a video, or in the bonus section, I believe, my friend Dr. Ted Coe shows this a little bit as well. But Ray's New Higher Arithmetic, which comes from 1880. So this is an 1880 arithmetic textbook. And in this 1880 arithmetic textbook, he says this, the problem, divide 5/6 by 4/7. So how many 4/7 does it take to make 5/6? Now look at the reasoning, look at the solution. 1/7 is contained in 1 7 times. Pause there for a minute. Sound familiar? Instead of starting with 5/6, they just start with 1. Instead of 4/7, they just start with 1/7. How many 1/7 does it take to make 1 7? And then 1/7 is contained in 1/6. 1/6 of that. So if you had 1/6 as much, you would need 1/6 as many scoops. So 1/6 of 7, which is 7/6. But then again, we didn't need 1/6, we needed 5/6. So 5 copies of 1/6. So 5 copies of those 7/6 would be 35/6. And so with much the same reasoning back in 1880, the standard way of thinking about arithmetic here was this. Now that leads to the algorithm. When you divide, you invert and multiply. That's the algorithm. But the thinking in 1880 was the same. And so yeah, here it is. All the thinking here in words, 5/6 divided by 4/7 is the same as 5/6 times 7/4, which is 35/24. So they argue, or they justify the algorithm. It will be seen that in terms the dividends have been multiplied, terms the divisor have exchanged places. Writing the terms thus is called inverting the terms of the divisor, or inverting the divisor. So we say invert and multiply. They say inverting the terms of the divisor. So this is not anything new. Sometimes I hear students or teachers tell me, well, this new math, I never learned it this way. This new stuff is really hard for me. And it's new to you, yes, but it's not new. This textbook is 1880, and so this is just how mathematics should have been taught from the beginning. And we've kind of strayed from that in our modern era of just answer getting versus the thinking. But I hope that you now see the thinking behind it as well. Hey, keep going. I got some more work to practice this, but you just need to let your brain think through this and keep working at it. Don't give up. If you have any questions, shoot me some emails, see if we can talk it through.